Alright, then we'll go on to look at number 45, where we want the derivative of arctangent of x over a. And if you recall, the derivative of arctangent of x is 1 over 1 plus x squared. And when it's a function of x, it would be 1 over 1 plus u squared, whatever that function of x is, times the derivative of whatever that function of x is. Alright, so let's look at number 45. And so that would be 1 over 1 plus the quantity x over a squared, and then times the derivative of x over a, where a we're going to assume is some constant here, and that's just going to be 1 over a. And so that should give us something like 1 over a times the quantity 1 plus x squared over a squared. And we could multiply the number 1 by a over a, or a squared over a squared. And when we do that, we'd get a squared over a squared plus x squared over a squared, and then we could combine the two terms over the denominator a squared. Now when we do that, we have the a on the outside and the a squared on the inside, and that can cancel with one of them. And that would leave something like 1 over a times a squared plus x squared, or a squared plus x squared over a, however you'd like to do that. But the important thing here is that that 1 over a can now be multiplied. Really, that's a also a to the negative 1. You could look at it that way, and it's in the denominator, so it really can move up to the numerator, and the final result would be a over a squared plus x squared. And I guess that's also pretty neat and concise there. So that's probably the optimal way to write something like that, to leave that type of a result. Right? So again, a lot of this is in algebra after the fact. And again, it's important. Yes, it's a lot of work, and yes, it's complicated and it's difficult, but still, it is something that is helping you and perfecting your algebra skills. So I think that it's definitely worth your while to think about those things and to try it and pick up the hints from the way that I'm going about doing it, and seeing if you can leave things in a little bit better form. Okay, then we'll try to go into number 47 and 49. For number 47, we're looking for the derivative of the arcsine of 3x over x. So we do need a quotient rule here. So I'll set it up. It's low, d high, and I'll just put a placeholder there for the derivative of arcsine of 3x minus high, d low. And that's just the arcsine of 3x because the denominator is 1 as x and its derivative is 1. And that's all over x squared. Alright, so we're looking to find the derivative of the arcsine of 3x. And so we're going to start with 1 over square root of 1 minus whatever u is, whatever that function of x is, quantity squared. And then we have to multiply that by the derivative of 3x, which is just 3. Now the 3 doesn't go in the denominator, it's 3 times that whole expression. So actually the 3 will go into the numerator. We could just put it there. Now just be careful that x on the first term, outside the first term, cannot cancel with the denominator because there's no x in the second term of the numerator. But we can rewrite the numerator as 3x over square root of 1 minus 9x squared, and then minus arcsine of 3x. Now this is crazy, but if we wanted to write this with a simple fraction, I would multiply numerator and denominator by square root of 1 minus 9x squared. And we end up with something like 3x minus square root of 1 minus 9x squared times the arcsine of 3x all over x squared times square root of 1 minus 9x squared. Anyway, that's I don't think that there's any clean way to leave this, and so we'll just stop at that point. And that's the derivative of number 49.